Welcome to this another lecture on digital computer electronics. We are continuing with the combination logic circuits, and here we are going to discuss about the encoders, decoders, multiplexers and demultiplexers. So first we are considering the circuit from decimal to BCD encoder. The decimal we know consists of 10 digits from 0 to 9, and these 10 digits can be expressed with 10 different keys from 0 to 9, and the pressing of each key is to be coded to form a particular number, to generate a particular code that can be given to an electronic circuit. So how we can encode particular decimal number is that we have to design a circuit which will convert the pressing of a key into a binary coded decimal number. The binary coded decimal number is a sort of binary number from 000 to 1001. So 0000 is represents 0 and 1001 represents the number 9. Now how to do this is that we have one least significant bit and one most significant bit. The least significant bit is the rightmost bit, and we can consider A as the least significant bit. So when this A should be 1, there are 5 conditions. When the number is 1, when the number is 3, when the number is 5, when the number is 7, or when the number is 9. So if number is 1 or 3 or 5 or 7 or 9, then only this A bit should be 1. In the same way, if we have the second bit, this is the least, A was the least significant bit, and B is the second bit, and it will be 1 at these conditions 2, 3, 6, 7. When the number is 2, the B bit should be 1. When the number is 3, again the B bit should be 1. In the same way, at the places 6 and 7, the bit should be 1. In the same way, the C bit should be 1 when the 4 is pressed, 5 is pressed, 6 is pressed, or 7 is pressed. The most significant bit D is 1 at 2 places only. That means 8 for 1000 and for 9 1001. So if these conditions are to be converted to circuits, we can have this decoder simply replacing the blacks with a circuit. When we are replacing the black box with the circuit, see that A is OR of 5 signals, B is OR of 4 signals. In the same way, C is also OR of 4 signals, and D is OR of 2 signals. Now this circuit will encode pressing of a key at the input into a binary code. So we press a particular key and a code is generated at the output. So this sort of circuit which converts a particular event into an electronic code is known as encoder circuit. So this is an encoder from decimal to BCD encoder. So we have the A being generated by the first OR gate, B generated by the second OR gate, C generated by the third OR gate, and D generated by the fourth OR gate. Now BCD to decimal decoder. This is the reverse of the things, that we had generated a BCD code and now we want that it should get transferred to a decoder signal representing 0 to 9 numbers, 10 events. So if such type of circuit is there, it will have A, B, C, D as inputs, but at the output it should generate the 10 outputs. 10 outputs, first output 0, 0, 0, 0 means A naught, B naught, C naught, D naught. In the same way, 9, A, B naught, C naught, D. So this is generating the 10 different codes from 0 to 9. So this is converting a BCD code into a decimal number representation. So this sort of circuit is reverse of what was the circuit encoder. So what is the decoder and encoder combination can be further understood in the following way. So let's have the assembly. We have a keypad having 0 to 9 keys, and this is a decimal number keypad, and this will be connected to an encoder circuit, the first circuit, and it will generate the 4 outputs. And those 4 outputs, if we give to a decimal decoder or display decoder, then it will give the decimal number representation back. So this is understanding what is the difference between now continuing with the combinational logic. We will now define a multiplexer. A multiplexer is a logic circuit having many inputs but only one output. The black box representation of a multiplexer is given here, where S0 and S1 are called select lines. The select lines provide a code of 2 bits, and according to that code, a particular line, input line, is connected to the output Y. We can go into the detailed circuit. A detailed circuit is like this, that we have 4 3-input AND gates whose outputs are OR together to form the single output Y. At the input, there are 4 different inputs C0, C1, C2 and C3. To these 4 gates, and then S0 and S1 lines generate code from 00 to 11, 4 codes to select a particular AND gate at a time. So the signal of that very AND gate, C0 or C1 or C2 or C3, will get connected to the Y line, output line. If we have more inputs, suppose we have 8 inputs, then the number of select lines will be 3, because on the 3 lines we can have the codes ranging from 000 to 111, means from 0 to 7, means 8 codes will be there to select a different 8 AND gates. This is a multiplexer circuit having 8 inputs and 1 output, and here we see that there are 3 select lines, S0, S1 and S2. Depending on the code generated by these 3 select lines, any one of the AND gates is selected to get the input connected to the output. Now demultiplexer is quite opposite to that of the process of multiplexing. It has only one input and many outputs. So if the black box representation is to be designed, it is like this, that this is a 4 output demultiplexer. The input line is connected to any one of the output lines depending on the code being given to select lines S0 and S1. So this is a 4 line, 1 to 4 line demultiplexer, and actual circuit of this type of demultiplexer is given like this, that we have 4 AND gates and a data line is connected to all of them, but the data line is connected to any of the outputs Y0 or Y1 or Y2 or Y3 depending on the select code given by S0 and S1. So this circuit is very simple, and let's have an assignment to complete a 1 to 8 line demultiplexer. You can try it at your own places. With this we come to end of this lecture. Thank you very much.